So hello all. So here I am here to explain the experiment starting torque of slip ring induction motor. So to perform this experiment, this is the circuit diagram. So here you can see the slip ring induction motor. So this is the stator winding of the slip ring induction motor and this is the rotor windings of slip ring induction motor. So both are star connected. So here what you are doing is that you are giving a three-phase supply to the stator winding, three-phase AC supply to the stator winding, and also you know the construction of slip ring induction motor. There are three slip rings that is mounted on the shaft, and the slip rings are to the slip rings there are three rheostat connected. To the three slip rings there are three variable rheostat connected, and we are varying this rheostat in such a way that we are adding the resistance to slip ring induction motor. So what our aim is that our aim is to plot the variation of starting torque with the variation of the resistance. So this is the nameplate details of the slip ring induction motor. It is 5 HP motor. Then the rated speed of the rotor is 1440 RPM. Then voltage is 440 volt. Then rated current is 7.5 ampere. Now this is the slip ring induction motor. So here this A1 A2 represents one phase status one phase winding, and B1 B2 represents status another phase winding, and C1 C2 represents status third phase winding. So as the stator is star connected, which means that the one of the three ends of the three phases has to be shorted. So here A2, B2 and C2 are shorted. Okay. Then as the circuit diagram indicates, here the circuit diagram indicates the rotor windings is star connected internally. So inside the machine the rotor windings are star connected, and from the rotor windings the connections is going to three slip rings. That is, these are the three slip rings, and from the three slip rings, next point of three slip rings, that is D, E, F. From there we are connecting three rheostats. That is, these are the three rheostats. So from D, it is connecting to one rheostat, and from E it is connected to second rheostat, and from F it is connected to third rheostat. And next end of the rheostats are shorted through an ammeter. Okay, there are three ammeters there. So the next end of the three rheostat that is connected to the ammeter, and then the ammeter's second terminal is shorted. Okay, and there is a voltmeter that is connected across the one of the rheostat. So that voltmeter is this. So this V by I ratio, that will give what? We are making the three ammeter currents equal, and the V by I ratio will give the value of resistance that is added to the three-phase slip ring induction motor. Start. So there is an auto transformer here. So the purpose of auto transformer is to use as a starter for the induction motor. So you know the starting method for induction motor. So here auto transformer starting method is adopted. So here there is a wattmeter to measure the stator power, and here an ammeter used to measure the stator current, and a voltmeter to measure the supply voltage. Let us do the experiment. So I am switching on the AC supply. Now what I am doing is that I am adjusting, or I am applying a small voltage to the stator in such a way that the current in this 3 ammeter, that is the rotor current, that is the current in this 3 ammeter is 10 ampere. That is the first step in the procedure. So I am giving a small voltage to the stator using this auto transformer, so that the current in the 3 ammeter is 10 ampere. So current in the 3 ammeter is almost 10 ampere. Now next step is we have to release the load. in such a way that the motor just starts. So I am releasing the load. So in a position when the motor just starts, I will stop releasing the load. So it will take some time. So you can see that the rotor is just about to start. Okay. So we have obtained the position where the rotor just starting to rotate. We have obtained that position. So in that position you have to note down the voltmeter reading, that is your Vs. So note down the voltage Vs, Is, then Ws. So note down the multiplication factor for Ws, it is 2. Then you have to note down the current IR. IR is 10 ampere, so that need not be taken. So you note down the voltage VR. This is the voltage VR, voltage across the resistance. So this voltage by 10 will give your resistance. That is the VR voltage is taking now. So note down that the voltmeter is in 25 volt range. So you have to take the lower scale value. So next you have to note down the spring balance reading. So in this position you have to note down the spring balance reading, W1 and W2. That will be W1 and this will be W2. So next step is that you have to increase or you have to include some resistance value. So to include some resistance value to the rotor, you have to adjust this 3 rheostat. That is, this is in minimum resistance position now. So you have to include some resistance to the rotor circuit. So for that I am increasing the value of resistance of the 3 rheostat. So I have increased the 3 rheostat resistance to some value. Okay, initially it is in this position. So now I have increased the 3 rheostat resistance to some value by moving it to the right. Okay. Now when you are looking at the 3 ammeter, it is seeing that it is not 10 ampere. So for that, what we have to do is that we have to adjust this auto transformer and make the 3 ammeter current almost equal to 10 ampere. So I am adjusting the auto transformer. So looking at the values, it is almost 10 ampere. So we have set the ammeter current 10 ampere for corresponding to this resistance added. Okay, so next step is that we have to again repeat the same as in the previous case. That is, we have to release the load in such a way that the rotor just starts to rotate. Okay. So you can see that the rotor just tend to start to rotate. So in this position we can note down the various readings. So this is your Vs. Note that the Vs is in the voltmeter that indicates Vs is in 600 volt position. So you have to take the upper reading. So this is your Is. So Ws. Note down the multiplication factor, it is 2. So IR is 10 ampere, no need to take the reading. You can directly take IR as 10 ampere. So this will be your VR. So VR voltmeter is connected in 25 volt scale. Now spring balance reading. This is W1. This is W1 and this is your W2. So our next step will be the same as that of the second step. That is, I will increase some or I will add some resistance to the rotor circuit by increasing the resistance of these 3 rheostats. Then I will adjust the auto transformer in such a way that the 3 ammeter currents are almost equal to 10 ampere. Then I will lose the belt. Then the rotor tends to just to rotate, and corresponding to this condition, we have to take all the meter readings. So from this onwards, we will only demonstrate the readings only. Okay. So this is the third set of reading. So this is Vs. So you have to note down that the voltage is in 600 volt scale. So you have to take the upper scale reading. Okay. So Vs is that. This will be your Is. So Ws. So current need not be noted because we have set that value to almost 10 ampere. So you can take it as 10 ampere. So this will be your VR, that is voltage across the resistance. Now to spring balance reading. This is W1. And W2. So next set of reading. This is your Vs, Is, Ws, ammeter is set as 10 ampere. VR is in the 25 volt scale. So next set of reading, note that upper scale has to be chosen for Vs. Is, Ws, don't forget to multiply it with the multiplication factor 2. So ammeter is set as 10 ampere. So VR is in the scale of 25 volt. Vs for next set, this is the Vs, Is, Ws, so IR is 10 ampere, almost 10 ampere. VR, lower scale has to be noted, that is VR. You currently next set of reading Vs, Is, Ws, IR is almost 10 ampere, VR, next set of reading Ws, and IR is almost 10 ampere, that is VR. Lower scale has to be taken. So this is the final set of reading. Vs, Is, Ws, current is almost 10 ampere. VR, lower scale has to be considered. So now we are stopping the experiment by reducing the voltage by using the auto transformer, then switching off the supply. So thank you for watching.